And here on the Open Align Show, we're going to be welcoming in 1339 AngelBotics from Colorado. It's a team we've had on for the last couple of years, and they are absolutely phenomenal. From their entire build process to their imagery as well, too. We're going to dive in with 1339, learn more about what they're currently doing for CAD, what their superstructures are looking like, and what their current progress is. And then talk about, of course, their imagery as well, too. A couple of years ago, Jazzercise, last year Kiss. You're going to learn more about which way they're going this year as well, too. And I personally love it as well. Let's hop into the Open Alliance Show. This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. And welcome to the Open Alliance Show. It's 1339 AngelBotics coming in out of Colorado. This is a team that we've been following for a long time here, and definitely returners to the Open Alliance Show. So much to talk about with team. Of course, we'll be going through some of the basic goals of Crescendo, the design processes, prototyping, and one of the things I love about your team, by the way, is the imagery that you bring as well, of course, in the background that we see too, but so much from this team here. So we got two fantastic students on. If you don't mind, y'all just introduce yourselves and let us know what you do on the team.
Hi, my name's Quinn. I'm a senior on AngelBotics. I've been here for 3 years, and I am the co-captain of the CAD and design sub-team.
And my name's Stoli. I've been here for about a year and a half now. Been doing just about everything, electrical, mechanical, a little bit of imagery, some programming, just about anywhere I can help out. And I've really enjoyed my stay.
Awesome. Well, we have a lot to unpack here, so welcome on. Let's get into how you approach the Crescendo game. What are some of your goals and strategies? Bring us up to speed where you're at right now in regards to that as we start to dive in more with your team.
So the goals that we set for ourselves for Crescendo, after a lot of deliberation, we decided that the most important thing for us was the auto, because the center 5 game pieces, which are up for both alliances to take, are worth 5 points, assuming they're scored in the speaker. So assuming we can get most, if not all of them, we'll have a very big lead at the start of the game. And another thing that was important to us was being able to score in both the speaker and the amp. The speaker because it's obviously worth more points than the amp, but the amp so that we could help get amplified points if absolutely necessary. And then for pickup, we decided that we wanted to be able to pick up from the ground, but with the option to pick up from the source in case something goes wrong with our intake. And then one of the most important things for us is that we decided that we wanted to be able to score in the trap, because after a lot of deliberation, we decided that in high-level matches, the trap will very most likely settle many endgames.
So one of the things I want to ask you guys with the trap is that we've seen a lot on Chief Delphi in regards to not attempting the trap for it. So what do you from your perspective on there, I agree with you. I think the trap, especially if you want to seed very high, can be a very important aspect for it. But how do you approach like the people who are like, don't do the trap? What was your, I don't know if justification is the right word, but what is your drive to really want to make sure you're doing the trap every time?
Well, I think a lot of it was that we wanted to challenge ourselves. It seemed like a big challenge, and that we thought it would be very fun to attempt. And beyond that, after looking at the point breakouts, the trap is worth a lot more than not a buddy climb per se, but the double climb. And so we thought that it would be much more worth it to be able to go for the trap than the buddy climb, especially because going for the trap and being able to climb on your own gets you like 2/3 of the way to getting that one ranking point for 10 points in endgame plus the 2 climbs.
Let's go into some of your design process. So we got your strategy set for things. Where are you at in regards to starting to get your design going? And then I know we show on screen right now too, you're starting to get some prototypes going as well too.
Yeah, so we have a lot of prototypes going. Like we've prototyped, this is just us building our alpha drive base, I guess you could call it, which we are going to hook a lot of our prototypes to. And then this was one of our first prototypes. We decided to test out the hamburger, as it's called, style shooter that was popular at the beginning of this, like week 1 and week 2. We decided to test various compressions with it and how consistent it was. And after a lot of research, we actually found in prototyping, we found that a hot dog style shooter like this is a lot more effective. As you can see, that building, for reference, is 50 feet. So this shooter can shoot very consistent.
More than enough.
Oh yeah, it can shoot very consistently from basically the entire field. And then
And on top of that, we wanted to make sure that we could do ground pickup. And because of this, we decided to do a mid-bumper intake, where it's not quite over the bumper and it's not quite under the bumper, so that we could avoid going in between the wheels and also avoid having our intake broken during a match. Because if you look at the field, it's a lot larger than most games are in sense of space, which means that robots are going to be going a lot faster on average.
And then another big thing for us with mid-bumper intake was that one of our big draws for over-the-bumper intake, which we were originally very set on, was that it had more reach than an under-the-bumper intake, which, at least in my opinion, was very valuable during auto, because many high-level teams are going to be using the fastest possible swerve modules, either Swerve X or MK4s with L4 gearing. And in that case, it's just a matter of who has slightly better reach for auto. But for mid bumper, it gives us practically the same reach as over the bumper, but with the benefit of we won't break from collisions.
And what have you seen in this type of prototyping so far that you've done? Is it true to what you are or what your expectations are for it?
It is very true to what our expectations were. So this was actually our first prototype of mid bumper intake, and we were running it pretty slow just to see how it would interact with the game piece before we decided to run it fast and potentially destroy everything. But for this, we found that it was very effective. It had very touch-it-on-it pickup. For this particular prototype, we were using cat tongue tape, as it is called, which we have found to be very good at gripping the game pieces. And then, yeah, from what we found, it works very well, just as good as any over-the-bumper intake you're going to find.
So we talked about, we've seen your drive, we've seen your intake. Walk us through some of the other aspects of your robot and what you're looking at doing.
Okay, so I'll go over the main design really quickly. So if we go to here, so this is our master sketch right here that we have decided. So this is the direction that we want our robot to go. So sorry for the mess of CAD here.
That's quite all right.
So as you can see here, this is the mid-bumper intake we talked about. We're just extending our drive base 5.25 inches forward to fit this in here. So we will end up having a 27 by, call it 32.525 drive base. And then our general design was to have a shooter that's on a wrist that can do a pass-through under an elevator. So it would pick up from here. We'll have a feed system that gets it into the shooter / indexer on a wrist here, so that it can then shoot out this side, which we are planning on using 3-inch stealth wheels. We'll go more into the shooter design later. Out here, so it satisfies one of our main design goals of being able to shoot or to pick up from one side and shoot out the other, which will make autos significantly quicker, as we won't have to rotate the robot nearly that much. And then if we want to score amp, we just have the go pass through under. And then we just extend the elevator. Sorry, hold on. We'll just extend the elevator to its max extension. Flip the master sketch, because why not? And then from here, we can score into amp out the front indexer bit. And as well as once we're climbing, which I'll demonstrate the climb in just a sec, we will be able to score in the trap, which this bottom thing represents the bottom of the trap, while staying within max extension limit. And for our climb, we have decided to go with something very similar for our to our 2022 robot, Jazzy Judy, where we have one static climber on the elevator demonstrated here, that when the elevator is at max extension, it will be able to grab the base. It will be able to hook onto the base of the chain. And then we will lower the elevator to this hook here, which is like our other climber on Jazzy Judy, a static static hook that's on a spring, so that as the chain gets pushed down onto it, it'll lower the hook, but then as you go up, as it gets above, it'll go down and be static again and keep us on there so that we can re-extend the elevator and score in the trap. So yeah, that's our design direction as of now. Oh, and we have a reaction roller in the front, as many teams have discovered, like Spectrum, are very efficient for this game as they keep you balanced while on the stage.
Well, something I want to ask you in regards to the arm that you have with the multi points on it. Have you analyzed kind of where your center of gravity is going to be for something like that? Because if you're lifting up that high, I'm assuming you're going to go with pretty lightweight elements up there as well too. But where does your CG kind of fall when you're at full extension?
So when we're at full extension, assuming we're climbing, the CG will fall, I would imagine, just basically in the center of the elevator, because although we have this piece of this big arm here, we also have the intake in the front counterbalancing it, which will allow us to maintain a rather steady robot. And then accounting for the fact that our center of gravity obviously won't be perfect, the reaction roller is there to balance us against the stage so that if we fall forward, assuming we will, we won't just fall off the chain.
What about from scoring in the amp? Where does the arm look like from there? Because one of the things I think about is like you want to always be able to move and score at the same time, sort of thing. So is that going to be extended to a certain spot while you're trying to negotiate the field too?
So for amp, we can have the elevator pretty low. We just need to extend a little, and then we can score from many positions, really. And this is one other thing we've decided for amp, is that after analyzing the game, we've decided that we want to be able to shoot down into the amp as opposed to up. We understand that a lot of teams have had success with shooting up into the amp, but at the same time, we think it'd just be much easier to program and much more consistent if we were shooting down into the amp.
And additionally, after prototyping in-house with an amp that we made, we found that you can throw up into the amp with the note, and it'll go in. But it's a bit more consistent when you're going down into it, because instead of hitting the ramp that's sort of angling at the top of the amp opening, you'll find that just dropping it in is a lot more consistent and means that the note will be scored easier, I'd like to say.
Looking at other aspects of your robot here, you mentioned before about shooter prototypes and that sort of thing. Can we dive a bit more into any other prototypes that you have done?
Those are the main prototypes that we finished now, but I can show you ones that we've been working on constructing.
Sure, yeah.
Like. So I will go back to the slideshow really quickly. Okay. So right here, you can see one prototype we've done. This obviously it's still in its baby stages, I guess I'll call it, but this is just an add-on to our under the bumper intake, or our mid bumper intake, as I should call it, where it will get sucked up into here and then get put into a series of orange belts that will lead it directly into our shooter. We have a plate that is ready to be made for that, and we will be testing that most likely at tomorrow's meeting. And then another one we have is this shooter that it's like the shooter I showed in there, where it goes in from the back, is stored into these and between these pieces of polycarbonate, and then is shot out the front with stealth wheels. And speaking of that, we've decided to go with stealth wheels because they're very lightweight. This game doesn't require moment to shoot up, as you're only shooting one game piece at a time, so that it's not as imperative to have heavy wheels like you would in a normal like 2020 or 2017 game where you need your wheel like really heavy and constantly spun up. So, and at the same time, these stealth wheels, at least from our experience, don't leave quite as much of the so-called Cheeto dust from the notes as many other types of wheels do.
Before we get into your imagery side of things, what are kind of like the major next steps that you're looking at accomplishing on AngelBotics? Like, walk me through like what the next week is going to look like for your team.
So the next week, it's going to be a lot of prototyping. One of the main things we're going to do is try to assemble our drive base, shown here, which a few things with the drive base. one of the unusual things we've done for this year is that we've decided to actually use 3x1 tubing instead of 2x1 tubing as our drive rails, because we want a very sunken belly pan. In our case, it's 1/2 inch off the ground. And the 2x1 just doesn't get the belly pan low enough. We were originally going to have the 2x1 with little 1x1 inserts holding the belly pan up. But then we thought about it more and realized, why not do 3x1? It gets our weight low, which is one thing we want. We want to be really stable this game. And it's just easier than having to deal with all of the tube inserts, gussets, and all of that nasty stuff for getting the belly pan low. And then another thing we've done.
We've added holes, I think, to reduce weight in the middle of the robot. And we've also decided that I think we want to find a better way to mount our electrical components.
And to do this, we've decided to map out our entire robot, or our entire electrical, our belly pan on the robot. So here you see these lines here. These are the wires running from the swerve modules. We have a Robo Rio here. We have the PDH here, et cetera, et cetera. And this has allowed us to as the first step, I should say, into one of our main goals that we want to accomplish, which is fewer electrical failures. And doing this will allow us to get a very precise belly pan, very compact and very effective at what it does. So yeah, going back to your question, that's what we want to do next week. We want to get this belly pan. We want to get this belly pan done. We want to get the drive base assembled. We want to get our prototypes built, get our CAD done for the intake and the shooter and even the elevator. Next week, our goal is to really have the entire CAD done, at least not done, the first iteration of the CAD done, I should say. And while doing that, keep prototyping.
Well, looking forward to that. One thing we got to ask you before you all leave, too, is one of the things I think of with 1339 is some of the imagery that you bring. 2 years ago, you alluded to before, you had the jazzercise theme to it. Last year, we had a KISS theme. What's the theme going to be for AngelBotics this year, and anything kind of special planned with that as well?
Yeah, so we decided to do a sort of mesh between Vaporwave and Outrun. And you can actually see that up on the sign behind us and on the slides. We're trying to sort of go for a very colorful with like sort of dark with colorful accents almost.
Think 80s like synthwave.
Yeah,
almost.
Totally.
Yeah.
Mm-hmm. If you also look at the slides, you can see some of the sign stuff that we have going on that we're planning to build this year.
So like the KISS signs that we had last year on top of our pit, we'd have these signs on top of our pit instead, with the sun with a big 2-foot light in the middle to shine across the rest of the pits. And then obviously a sign that shows 1339 AngelBotics, because we got to represent.
Mm-hmm. And then for the shirts, we were planning on doing a sort of dark shirt with the AngelBotics logo for this year on it. And in the logo, you can obviously see the triangles, the team number, and the name, like we do every year, but shown in more of an Outrun, Vaporwave, synthwave style.
Well, Synthwave definitely speaks to me as somebody who grew up in the 80s and 90s as well, too. So looking forward to that as well. Who knows? Maybe you'll make your own song for that, right? So very much so looking forward to what AngelBotics is going to bring. Thanks a lot for taking the time, y'all, to go through your process. We can't wait to see what you have. And if you haven't already, make sure you check out AngelBotics' OA build blog on Chief Delphi as well, too, to stay up to date with all their progress. Thanks so much. We look forward to seeing what you bring in the future, and can't wait to see it. Thanks a lot.
Thanks for having us.
This video on fun is brought to you by viewers like you, and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs, where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.